is the application. And the quadcopter is a superior platform for what we call hover and stare applications.
Okay.
I'll give you an example, a SWAT situation.
Okay.
Op puts a $50, $60, $80,000 quadcopter in the back of his patrol car. He goes to a SWAT situation. He pulls it out. It stays up over the house for 45 minutes. Gives them the situational awareness that they need, and he pulls it, and then they bring it back down. There are a number of hover and stare applications in urban environments for going in between buildings and so forth. You wouldn't use our system for those kinds of applications. It just wouldn't make sense.
Right.
On the other hand, you wouldn't use a hover and stare quadcopter to do pipeline surveys.
Right. Yeah.
So the point is that the press and folks tend to think of UAVs, drones as a monolithic industry. You know, the quadcopter is as different from us as it is from a Predator or a Global Hawk.
Right. Yeah. Well, let's talk a little bit about sort of the perception, we've already sort of touched on that this technology, because of its use in the two wars overseas, as well as for border surveillance. I mean, if you go down to Key West, Florida, one of the first things you see are those hovering big blimps that are there that are radar looking for, people trying to smuggle in drugs.
I was sailing in the Bahamas. They had them there too for drug interdiction.
Right.
Actually, the privacy concerns I think are legitimate. Our Falcon Vision payload can identify an individual at 300 plus meters, and that's in the day, and it's 120 plus meters at night with infrared cameras. And so sort of unfettered use and applications of these things, or having them in the hands of the wrong people, I think the privacy concerns are very legitimate, and the FAA is addressing those issues. Having said that, it's just another tool. The tool itself is not bad. The tool itself can do wonderful things. For all kinds of missions. It's like anything else. It's whose hands that it's in, and so it's like phone taps or anything else. So yeah, if you had every paparazzi out there with a quadcopter with a DSLR camera on the bottom of it that wanted to peek into some celebrity's swimming pool, that's a very legitimate issue. But for responsible folks using them in responsible ways, reasonably well, I don't want to say regulated, but monitored. I think it's an addressable concern, but a very legitimate one.
Yeah. Well, two examples I think that were good examples that I've seen recently. There's a couple of TED Talks on it. One was a group that is using drones similar to yours to do wildlife surveys in Africa. And then the second one, also in Africa, interestingly, but they're using a quadricopter with a concept of delivering medical supplies to remote villages that are difficult to get to because of either a non-existent road or impassable roads during rainy seasons and things like that. So those would be, I think, really two sort of excellent applications. I'm not sure I want to get packages delivered from Amazon by...
and I don't either, because I don't want it falling on the cat or the dog or scratching the paint on my car. But if you think of applications like precision agriculture, for environmental surveys, we have a demo lined up to go count wildlife on the Danube River Delta, for example. There's using a different kind of sensor, a medium wave infrared sensor, which we've developed. We haven't developed a sensor, but we've developed we've developed it to carry it on our aircraft. You can detect what's called fugitive hydrocarbon emissions, which means gas leaks or leaks from barges, or you can also use it to detect underground anomalies like leaking water pipelines or gas pipelines, or leaking levees or things like that. And so there's an awful lot of things that you can do with different kinds of sensors on UAVs that are very positive type of applications. And so the surveillance and the system, like our system was designed for what they call ISR, intelligence, surveillance, and reconnaissance. But it turns out, as I mentioned before, that attributes that you need to be successful in those applications work equally as well in lots of other applications.
Yeah. Well, so the FAA, for example, here in the United States, the FAA has essentially said you can experiment with this technology in 6 states: Alaska, New York, North Dakota, Texas, North Carolina, and Virginia. What specifically are their concerns? Why can't I do this in South Dakota, Nebraska, Kansas, Oklahoma?
Their primary concern, which is a really legitimate one, is integrating these things into the national airspace. I mean, you don't want someone flying even a 25-pound system like ours by an airport and getting sucked into an engine when the plane is taking off or landing. You also don't want them falling out of the sky and crashing people on the head and so forth. And so they have a very legitimate concern there, and in particular, and the reason why they picked those particular locations for the 6 centers of excellence is because they provide a diversity of geography and diversity of airspace issues. The ones in New York and Virginia, for example, they're obviously pretty crowded airspace. We have a very good relationship with the University of Alaska Fairbanks, which bid on one of those centers of excellence, along with the states of Oregon and Hawaii, and they actually are one right now. And they actually have, I believe it's a PhD program in UAV technology. They're one of the most technologically adept folks, or institutions, let's put it that way, out there for this nascent industry. And really what the FAA picked these centers of excellence for was to collect data on mission data and things like that, and then data on the kind of systems that are operating, so that they have the data and the knowledge to effectively integrate UAVs into the national airspace. And so that's a little bit of a background on that. Our view is that you have to be extremely respectful of their concerns. And we're, as I said, unlike a lot of small startup companies, just by dumb luck, we have an international sales force with folks on the ground around the globe, and different countries have different approaches to how they're solving that problem, and that's going to give us a leg up on getting into the market. I don't think the U.S. market's going to be, it's going to be severely constrained until at least 2016 because of the FAA issues.
Okay, so sometime after 2016, you can begin to see this widening and opening up then.
Right. I mean, they're selling systems on a very limited basis right now to law enforcement and things like that. But it's not, it's a pretty cumbersome process to be able to legally fly a system here in the U.S.
Take us on a typical. I'm curious, holding a pilot's license myself.
Okay.
I'm curious as to, how you fly one of these things. I mean, so if you would just kind of briefly take us into the field.
Sure.
How do you launch one of these things? How do you fly it? Do you sit there with a little joystick? And then how do you land the thing and recover the thing? Let's put it that way.
So everything in our system is packed into a Pelican case that's about 80 inches long, and in that Pelican case there's the fuselage, there's the payload, which is usually built into it by that point in time. There's a couple of wings. There's the vertical tail section and the horizontal tail section. So you pull it out of the Pelican case. It snaps together relatively easy. When I go down and show you the system, I can show you how all that stuff works. And then it's launched with a catapult. And so we did lots and lots of test flights using wheeled launch and recovery, just on a runway. And we can offer that option, but as a pilot, that creates a tremendous amount of drag. And our lead engineer designer is a very skilled sailplane pilot, and so anything that he remotely thinks of drag, he hates. And he's designed a very clever catapult system that actually uses the Pelican case as a base. You crank it up; it's like a gigantic bungee thing. It shoots it up. It shoots it at a certain speed. 20 milliseconds after it gets off the catapult, the electric motor comes on and it takes off. Okay. Now, before you've actually done that, you sat down and you stuck your antenna into the ground and you booted up your computer on which is what's called the ground control station and the ground control station software. That in turn is hooked up to a small radio that's about the size of 2 decks of cards.
Okay.
And you've laid out your mission. You've downloaded maps. You have a map in there, and you've laid out your mission profile, which is really waypoints and altitude. And you kind of put into it what you want to fly. And there's all kinds of things that you can do automatically, grid searches, figure eights, things like that. But you basically lay out the waypoints in the altitude. The thing takes off, it flies to its first waypoint, and it's basically, it can fly autonomously from that, from that point on. It goes from waypoint to waypoint to waypoint. Meanwhile, you're downstreaming your data or your images and so forth, and you're looking at whatever you want to look at or accumulating whatever data you want to have. And the way we build it, and the way we would recommend that, actually on a second computer, we recommend having 2 operators, not necessarily a pilot, but someone who's paying attention to the aircraft,
Right.
Power and all that, and then someone else who's paying attention to the payload, because there's a lot of stuff that the payloads can do. And so you're flying that mission. The guy's looking out there, and the payload operator, and he says, "Hey, look, if there's something over here, another moose or something,
Right.
you can direct it over there, and then you can say, come back. Okay, so you go and you fly your mission, the pipeline monitoring, whatever it's going to be, wildlife counting, poaching, surveillance, you call it, whatever your mission is. Your last several waypoints to bring the plane home or to wherever you want to land it. You come in a little bit over stall speed. You click a button and a parachute comes out,
Okay.
and the plane is landed upside down
Right.
with via parachute. And you run over and you get it, and you're done. So that's a typical mission.
Okay. Now, is there so when you say when he redirects the aircraft to go look at that other moose, is that done just simply by typing in coordinate changes, or is there a joystick that allows him to fly it over there?
There is a capability for what's called RPD mode, where you actually plug a joystick into the computer. You can do it that way, or you can do it with a mouse.
Okay.
And in certain applications, when you're in relatively close range, you can also use a RC controller, like the RC guys use for that. But yeah, you can use a joystick or you can use a mouse. You can use a touchpad on the computer if you want to. You're just putting waypoints on a map, basically.
Okay. Well, let's talk here real quick to sort of start wrapping things up a little bit. Let's talk about production plans here. You're located in Albuquerque.
Mm-hmm.
Is this where all those systems are sort of integrated, or are you guys actually building the airframe? And maybe, is this a fiberglass airframe?
No, it is. First off, our business model is that we have partners who make stuff for us. So we have a guy who makes our airframes for us. They are mainly carbon fiber composite, although there are pieces of them that are fiberglass because of the RF, so you can communicate with that internal antennas and stuff. But when we go back there, I can show you those in various pieces of what they look like. And then so we have a composite manufacturer who makes those to us, our design and everything. We have someone else who makes our payload for us. That's a pretty sophisticated, or payloads. They're pretty sophisticated electronics components. And then we have other suppliers. Some of the stuff is commercially available. Some of it's made to our specs. And our manufacturing, if you want to call it that, is really final assembly and QC. And we just now stepped into what I would call limited scale production. We're building 3 systems right now. Our guys are writing orders, and as the orders come in, we'll step up that production. So really, what we are is an assembly and QC shop is really what it boils down.
And you got approximately how many people working for you now at this point? We
have, with our test pilot, we have 8 people here, and then there's actually 5 people on the payroll in our sales and marketing group, which is a separate but affiliated company.
Okay, all right, very good. Okay, pricing. If somebody wants to order one of these from you, what's it cost, and where can they learn more?
It depends on the configuration and the kind of payload that you want, but a standard configuration system, which we would call our medium wing system, which has a wingspan of about 13 feet, the one that stays up all day, is in the range of $225,000.
Okay.
There's different things that you can do that increase that. There are some things it's that ballpark, and depending on the configuration that you want, how many you want to order, and stuff like that, we can,
Right.
It varies a bit. And to order them, you can either contact us. Chances are, I would simply refer that contact on to our sales and marketing team.
Right.
We work very closely together, but that's basically where we are right now. We're fully exportable. We don't have any export restrictions other than to a handful of pretty obvious countries that we probably wouldn't want to sell to anyway because we couldn't get paid by them.
I would think probably someplace like North Korea would probably be
Yeah,
one of those. Iran might be another.
And yeah, but and even some of those countries we could sell to, but by and large we're not we're an approved work item with the Commerce Department and so forth. So it should be okay.
All right, very good. Well, that's super. Thank you so much for taking the time and talking to us about the Silent Falcon. Very cool.
Okay.
Let us know when you get the first ones out in the field here in Nebraska. I want to go see it.
Yeah, well, because I said we got a couple of important shareholders up there.
All right, sounds good. All right. Thanks a lot. I appreciate it, John.
Okay, thank you.
Okay, bye-bye.